Hello everyone. I'm Mrs. Prajwal Gaikwad, Assistant Professor from Computer Department of ASSMS Institute of Information Technology, Pune. Today I'll be discussing a topic of functions from discrete mathematics. So what a function is? A function in maths is a special relationship among the inputs, or you can call it as a domain and their output known as the codomain, where each input has exactly one output and the output can be traced back to its input. We'll see some examples on this. So there are four types of functions. You can say one is general function, second is surjective, next is injective, next one is bijective. So a general function is where you can say every A. So we are giving or pointing every A to a member of B. So here it is one to many is not there, one to one is there. Or you can say uh, from A it is pointing to B, but single A cannot point to multiple B's. So one to many is not okay in a general function. So here A is pointing to two B's, so it is not a function. So if A has many B's, you can say that it is not a function. But B can have many A's. So many to one is okay, but one to many is not okay in the general function. So in the surjective function, it means that every B has at least one matching A. So you can check every B has at least one matching A. So you can remember it as every B has some A. So it is a surjective function, not injective. So the definition is a function f from set A to set B is surjective, also called as onto function, if and only if for every y in B, there is at least one x in A such that f of x is y. In other words, f is a surjective function if and only if f of A is B. So every B has some A. For example, if you say x is this set 4, 5, 7, 8, y is 1, 3. So f is, suppose this is the output given. So 4 is pointing to 1, 5 is pointing to 3, 7 is pointing to 1, 8 is pointing to 3. So here all the elements of set y 1, 3 contain a domain element on set x. That means the elements 4, 7 of set x have image 1 because 4, 7 are pointing to 1 and both elements 5, 8 have image 3. So 5, 8 has image 3. So here 1, 3, this one y is known as range of the function and that range is equal to y. So this f you can say it as x point to y is onto or a surjective function. Now injective is not surjective. Here B cannot have many A's. So here the pointing from set A to set B is only one. We cannot have multiple like from set A you cannot have multiple multiple arrows coming to set B. So injective means we won't have two or more A's pointing to same B. So many to one is not allowed in injective. So as it is also a function, one to many is not okay, but we can have B without matching A. That means we can leave some elements from set B. So it is one to one. We can see the image as one to one. So again, in the definition part, we can say that we can take some examples. Suppose f of x is x plus 4 from set of real numbers R to R is an injective function. So imagine f, suppose x value is 4, then f of x is 8 because f of x is x plus 4. So 4 plus 4, 8. Now what I can say that is f of y is 8. What is the value of y? Again you can put the values here. So it can only be 4 because if you want to match this, it is should be 4. So x equal to y. Now bijective means both injective and surjective. That means 1-to-1 on 2. So 1-to-1 correspondence is there between the members of the set. So there is 1-to-1 correspondence. All the numbers are mapped onto B. There is no order, but every member is connected to all other with some function. So it is 1-to-1 function, you can say, which is both injective and surjective. So example is, suppose f of x is x square, then f of 2 is 4 and f of minus 2 is 4. So this is an example. Now this is from the set of all real numbers. R is not bijective because we can have two values which are pointing to the same, because 2 raised to 2 is again 4, minus 2 raised to 2 again is 4. So this example is for the numbers, the set of positive real numbers. So here we are mentioning it as positive real numbers because f of 2 is 4. Now composite function, here you can say it is a type of function whose input is to another function. Like take function f of x and g of x. So f of x we can map to g of x. Suppose f of x given is set B to set C and g of x is mapped to C to E. That means C is overlapping, you can say. So here G to F, yeah, we are writing the composite function in this format, G O F, where it's a function that maps elements from B to E. So here it is GOF, you can represent it as function G of f of x. That means function of x. When I want to write f related to G, at that time I'll write f out in the outer side, G of x. So if f of x suppose is 5x plus 2 and G of x is x plus 1. So how I'm going to write FOG? It will be f G of x. But G of x is what? X plus 1. So put value here x plus 1 into here again. So it will be, in place of x, it will be x plus 1. So it will be 5 x plus 1 plus 2. Likewise, we can relate f to f, the same function, or g to g. So it will be represented as function of x, function g of x. Likewise. So these four are, you can say, the composite function, where one function is input of the other. Here fx is input of g. Here fx is input of function f. Gx is input of function g. Likewise. Now identity function is a function considered to be identity function where it returns the same value as the output that is used as an input. So here by the diagram you can say this value 1 is pointing to 1, 2 is pointing to 2. That means the input as well as the output is same. So when I want to write a function, here the output will be 1 to 1, 2 to 2, 3 to 3. So it is onto itself. So it is represented by identity function I. So here an example is given, g of y, suppose this is the function given, then g to g, the composite function for identity, you can write it as g to g. You are supposed to solve this given function by putting these values. So the answer is y, because it is an identity function. You can check the value comes out to be y only. After solving, it gives a identity function. So we can say that when you put this value given the equation, it comes out to be the identity function. Now the partial function, now from the diagram only we can say that here not all members of a given one set are pointing to the other. Here all are pointing, but partial function, as the name only suggests, it partially works. Not all members are pointing to the next. Invertible function, if on reversing the order of mapping, we get the input as the new output. That means just change the order. Now, in other words, suppose function f whose domain is in set A and image in set B is invertible if f inverse has its domain in B and image in A. For example, if a of x is a function fx 5x plus 2 and b of y is y minus 2 by 5. Here, by putting on the values, suppose for x as 1, the output comes to be 7, and for b of 7, like here, when I solve a of x, the value comes out to be 7. But when I put b of 7, the value comes out to be 1. That means both are interchanging, you can say. So then we call it as a invertible function. So that's all for now. Thank you.